Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Shafiq bin Nasaruddin, and the purpose of having this presentation is to introduce you guys on what is horizontal wire testing. But before that, I would like to introduce you guys who's our team members. First and foremost, Azim Alamjir, Vinod Jayapalan, me myself Shafiq Nash, and last but not least, David Abraham. But before that, I would like to ask you guys what is horizontal drilling and what is horizontal wire testing. Never mind, I'll brief you guys on what it's all about. Next slide. Horizontal drilling, it is a process of drilling and completing for production which begins as a vertical or inclined linear bore which extends from the surface to a subsurface location which is just above the target oil or gas reservoir called the kickoff point. And horizontal well testing, it is an acquisition act to detect hydrocarbon properties and characteristics of the underground reservoir where hydrocarbon is trapped horizontally. What horizontal well testing can provide us? It can provide us with initial reservoir pressure, permeability thickness, skin, wellbore perforated length, permeability, and effective permeability. And for information, horizontal well testing is useful for those reservoirs that have exploration and development of inaccessible location. Secondly, old reservoirs that no longer have adequate drive mechanism. Thirdly, thin layered reservoir, and last but not least, natural vertical fractures. End of my presentation. I would like to pass the presentation to David Abraham. Please welcome David. Thank you to Vinod for a very good presentation. Now I would like to introduce you guys on intermediate time linear flow regime. Okay, for information, the characteristics of intermediate linear flow regime is that the horizontal flow here, we can see from this diagram, the horizontal must be longer than the H, which is the vertical flow regime, which it occurs if LW is more longer than H. Okay, and the slope of P versus square root of T is controlled by this equation, which is this is the slope. Okay, so this is the slope when it is on a Cartesian plane, but from this graph, right, it is a log graph. So, and this is the intermediate linear with the slope of half 1/2. So how can from this equation move to half slope? So it's very simple. I'll teach you guys on how to get it. So basically P is equal to square root of ky CT LWH over mu times square root of T, which is the x, right? P versus square root of T. So y is equal to mx plus 0. C is 0. So we log both sides, right and left and right hand side with log. Okay, and after that we want to make it from square root T to T, right? From T here, P versus T. So it's very simple. We square both sides, both left and right hand side with squared, and the square cancel at here, and square root of T cancel, left with L squared H squared over mu squared and P squared over here as well. So log P squared is equal to ky plus T CT LW squared H squared mu squared times T. Okay, and the law of log, right, it represents log this one plus log T, right? And the squared at P squared, we move it to the front, and 2 we move it to the right hand side and make it half log ky plus T CT L squared H squared over mu squared plus half log T. And we can see that this is y is equal to, this is C, half log ky plus T CT L squared H squared over mu squared, this is C, plus half log T, and half is the slope, log T is the x. So that's how we can get the slope with half. Okay. Okay, now we move to the intermediate linear flow pressure equation. From the linear flow analysis, PWF versus square root of T plot, we can find that these two is the equation. PI minus PWF is equal to all this equation, and we can find that SZ at the back here. And when we make SZ as the main component, we'll find that this is the equation of finding SZ. So these two equation is the equation of intermediate linear flow pressure. Thank you.
Hello everyone, welcome. Today I'm Vinod and I'm going to be briefing you about horizontal well testing, especially in early radial flow pressure equation. All this while we have been learning about early radial flow in a vertical well, but this time let me brief you about ERF, early radial flow in a horizontal well. Now why is it important? You must know that the flow regime is always important to every reservoir engineer. And horizontal flow is just another newer form of excavating wells in order to extract hydrocarbons. We need to know two things. Flow is not affected by reservoir boundaries. The reservoir can be extremely huge, but because this is in its early phases of radial flow, it will not be affected. But what will be affected would be the wellbore storage effects, as in the early stages, the well is closer to the wellbore than you think. Second option is the flow is similar to radial flow beyond your vertical boundaries. Meaning after you've passed your vertical boundaries, you will see a similar type of flow to your early radial flow. Now, as I've already told you, the wellbore storage effects are important. And we move to the second part. You will see the wellbore storage effects will be highlighted in this part here, in the early stages of the log delta P and the log time graph. And then you have this part, which is your early radial flow. You will also have a derivative of your pressure as a complement graph at the bottom. Now, this is the position of where early radial flow is. And as said earlier, it is not affected by your reservoir boundaries. This flow that you see here will be present and similar to outside of your vertical boundaries. So as you get readings from this part of the graph, you will notice that the same readings will be outside. Simple. Next part is the equation itself. You know that it is PWF versus a ln T plot graph. But you notice that there are new terms here, LW, ZW, H, KV, and KH. You need to know K and H, Ks are the permeabilities that are in a direction parallel or perpendicular to your wellbore. LW happens to be your completed length of the well, which in most drilling cases would be the measured depth minus your vertical amount. We begin our early radial flow with the drawdown equation, which is Pi minus PWF. And then you also have your gradient, which is MERF, but in this case it's expressed as 162.6 QSC B mu over KH KV square root LW. On top of this, you will also know that you need to require to find a square root KX KZ. And lastly, you also need to know the calculation of the altered permeability skin SD. Now, if you notice, this is a very simplified chart that I have created here. If you check KXKZ SD, you notice that once you simplify and find these terms, you'll be able to identify what is your early radial flow. So we already found the gradient, which is MERF, and with that you can find KXKZ, and with that you can find your altered permeability of the skin. And with that, once you find your early radial flow, it will help you monitor your reservoir and conduct well tests more efficiently. Thank you very much.
Hello, my name is David Abraham. So today I'm going to talk about basic flow regime. There's three flow of regime that you guys should know. Early vertical radial flow, intermediate time regime flow, late or horizontal regime flow. Okay. What is early or vertical radial flow? Okay. It occurs because convergence of flow, the slope of P versus in controlled by this formula. While for intermediate time regime flow, it occurs if LW is greater than H. Slope of P was the square root controlled by this formula. Late or horizontal regime flow. Slope of P versus int controlled by this formula. Okay. For vertical wells, the radial flow is governed by the horizontal well. For horizontal well, early radial flow is governed by the geometric mean of Kh and Kw, while late radial flow is governed by horizontal permeability only. Pressure behavior of horizontal well. This is early radial slope, this is intermediate in linear, this is late linear. If you see each in these three parts, each one have their own formula. So when you see a pressure of behavior of horizontal well, you should know that there's three different stages and there's three different formula to be used. Thank you.
Alright, you just learned about early radial flow and intermediate radial flow. Now, let's move on to the late radial flow. Late radial flow are also called pseudo-radial flow is actually when the slope of P versus T is controlled by this expression, that is the permeability in the x direction multiplied by the permeability in the y direction and multiplied by the thickness of the formation divided by square root of viscosity. For a horizontal well, early radial flow is governed by the geometric mean of permeability of horizontal and vertical permeability. But for late radial flow, it is governed by the horizontal permeability only. What is meant by horizontal permeability only is that you can see in this picture that for horizontal permeability, we only have the permeability in the x direction and the permeability in the y direction. So we are going to ignore the permeability in the z direction because it is a vertical permeability. For a late time radial flow, where the PWF versus long T plot, there are three equations that you can use. The first one is, if you want to find the PI minus PWF or the delta P, you can use this equation to find it. And for STRG, you can use this equation. And lastly, for the SP, you can use this long equation to find the SP.